Good morning, sir. Good morning, students. Welcome to the new class of physics. Today we are going to discuss another important topic of the chapter 10, that is mechanical properties of solids. Okay, so let us start with. So today we are going to discuss about this stress. Now let us understand what is stress. We know that when we apply the force on any object, that force is able to change the shape of the object, right? Now that applied force is applicable in three ways. Let us see how. The force we can apply in three ways: lengthwise, right? Means we can apply the force along the length of the object. If that let's say the object is a one dimensional object, like a wire, like a rod, like that. Okay, we can apply the force area wise also. Area wise means we can apply that force along that surface tangentially. Okay, that kind of force create the change into shape in another way. Okay, the third way to apply the force is we can apply the force to contract the entire volume. So third way we can apply the force volume wise, right? Now in particular this session we are going to focus when the force is applied lengthwise on the object, right? Now let us see. Let us take the one rod of uniform density and length L, for example. Now if I try to stretch this rod from the both the side, then we know that the length of this rod will be changed. Let's say for example the length of this rod is increased to delta L, like this. Okay, so amount of delta L increment we can see into the length of this rod due to this applied force, right? So that change into length we define as the deformation. Okay, so deformation means the fractional change into the shape of the object, right? That deformation, in particular this situation, we call it the strain. Okay, so the equation of strain we write as change into length divided by original length. That we also call the fractional change into length. Now that this fractional change into length occurs due to the force applied lengthwise. Now we know that when we if that applied force is within the elastic limit, now we know what is the elastic limit that we have discussed already, right? When that force is in elastic limit, then if you remove that external force, then that length or that rod will try to restore its force. Now how does it restore its force? Because there is a restoring force inside that rod. Okay, so that restoring force is responsible to restore its shape. Okay, so that restoring force, if we consider, then that restoring force is also proportional to this external force. Now so the definition of force we can take according to the restoring force created into this rod. So the stress we can define as the restoring force created inside the rod, not the external applied force we are talking about. We are talking about the restoring force which is created inside the rod. So that restoring force created per unit area, this ratio we define as the stress. Okay, so stress is what? It is the restoring force which is created or which is produced due to the applied external force on it. Okay, so that is called stress. Now the force on this rod we can apply it in two way, right? We can stretch the we can try to stretch this rod, or we can try to compress this rod. So when we apply the force to stretch this rod, then this stress is called the tensile stress. Okay, so this stress is tend to stretch the rod, right? And the another stress when we try to compress that length is called compressive stress. Okay, so compressive stress is to compress the length or the compress the object lengthwise. Okay, so we have here two type of stress, right? And the strain is produced in this rod, it is also along the direction in which we have applied the force, or we can say along the direction of the rod. Okay, so this kind of strain is called the longitudinal strain, or longitudinal strain also we pronounce, right? So let me write here, longitudinal strain, that we write as delta L divided by L. Okay, so this is called stress and strain. So I hope you understood very clearly the meaning of stress and the meaning of strain. Stress is what? It is the restoring force which is produced inside the rod, or we can say the object which is, let's say, one dimensional, and the strain is, we can say, as the deformation, or we can say the relative change into its length, right? So let us keep up to here for today. So this is it for the today's session. Okay, now in the next session we will discuss some more topics about this chapter. Thank you.